In this video, I'm going to talk about a simple way to tell if you have sufficient airflow in an HVAC system. Save 10% off Vito Pro Packs for a limited time at jacksonsystems.com using the Save 10 Vito ST promo code. Trying to make this as simple as possible so that you have a minimum of tools and a minimum of effort so that you can do this on any call or install that you want to do. All you need is two different psychrometers. So you want something you can put in the duct. You don't want to put something all the way at the return grill or all the way at the supply grill. You want something on either side of the equipment. So I used to use these UEI thermometers. You can use any sort of wireless thermometers you want, but they have to be able to measure dry bulb and relative humidity. Or you have to be able to make the calculation, but might as well have the readout to make life easier. You want to do these measurements whenever it's about 70, 78 degrees in a house or structure. You don't want it to be too cold or hot or it throws off the measurements. First, you want to find out what relative humidity you're working with, because that's going to determine how wide a split you should have from one side of the equipment to the other side. So let's say you have a typical 50% relative humidity. Then you should have a split from return to supply dry bulb somewhere in the neighborhood of 17 degrees, 17 maybe up to 18, right there in that area. So if you make your measurements, dry bulb on either side, and you have 14 or 13, you know that there's either excessive airflow, which is more rare, or there's an issue in the refrigeration circuit, or the system has some sort of breakdown, which is more likely. If you have a split that's in the low 20s, then you more than likely have low airflow because the air is moving slower across the coil. It's getting colder as it passes through the coil, and that's why you have that wider split. And you can address this by measuring CFM directly with any number of devices, but to get a rough idea, this is an easy way to do that. Now, if you put your probes in there and your humidity is up to 80%, it's very, very humid in there. In fact, it's probably better to run the system for a while and try to dehumidify a little bit. But if you're all the way at 75, 80%, then your split's going to go way down because your system capacity has to address this latent load that's on the system. And it takes a lot of the energy out of the system instead of using it, for lack of a better explanation, instead of using it to cool the actual temperature. So it's taking water out of the air and dehumidifying. Therefore, your split may be as low as 13 or 14 degrees, and that's normal. Now keep in mind, if you get down to 50%, that's no longer acceptable. So you have to know where you're at so you know whether the split is good or bad. This is the issue I always had with home inspectors. When you're looking for a certain split, but they don't measure the relative humidity, then you really can't address what the actual split is. So if you see something that's way too low, like 12 or 13, they may think there's a problem with the system. But if the humidity is very high in the house, like the system's been off for a long time, and you live in a humid environment like the entire southeast United States right now, including where I'm at in North Carolina, it may really throw you off. By the same token, if you have extremely low humidity, then you're going to get a lot of sensible cooling, which is that actual temperature number that you see on a thermometer. So if it goes in at 80 degrees, it may come out 60 degrees. It may be a 20-degree split because you have an extremely low relative humidity, like 30 or 40%. So basically, all you're looking for is you want your relative humidity, and then you measure your split. Either side of the equipment, don't go too far from the equipment, or else your ductwork becomes a factor. And if your ductwork is poor or old, or just poorly done, it's going to throw off your assessment of airflow. If you go to the supply grill or the return grill and do the split there instead of at the equipment because you don't want to go up and drill any holes and stuff like that, then you may get tricked into thinking you have the wrong airflow when you don't, or vice versa. So the best thing is to go up to the equipment and do that little bit of work right there. It's pretty simple, and it'll give you a lot better idea if your airflow is doing okay, too much, which is usually never the case, too low, or your system may have an issue if you have a low split when your target is higher. I hope this helps you guys out there. Feel free to ask any questions in the comments, and I will see you guys on the next video. God bless all of you.
Save 8% off your order at TruTechTools.com by using the Shop Talk discount code.